So we're solving for x when we don't have nice easy numbers. From the index form, you take the log 10 of both sides. So in the same way that we can get the square root of both sides or multiply both sides by 2 or whatever, taking log 10 of both sides means I have log 10 of a to the x equals log 10 y. Once you've done that, the third log law says I can do what with this power of x? Yep. Put it at the front. So this is x times log 10a equals log 10y. If I've got x times log 10a, how would I get x on its own? Divide both sides by log 10a, so x equals log 10y on log base 10a. Since my calculator will evaluate log base 10, this will now be in a form where I can solve for x using my calculator. So let's go back to this example. 2 to the power x equals 7. So our steps are to take the log of both sides, rearrange, and use the calculator. Take log 10 of both sides. Log 10 of 2 to the power x is log 10 of 7. Bring your x out to the front. X log 10 2 is log 10 7. Then this is x times log 10 2, so you divide both sides by log 10 2 to isolate x. And then you grab your calculator, which you totally left right here. So, log 7. Okay, this is not very helpful. Let's borrow someone else's calculator, thanks. Sorry, I packed mine away for the lesson. So, log, it is log 10. You don't have to tell her it's log 10. The only thing this calculator does is log 10. So log of 7, with the brackets, divided by log 2, close your brackets, and that's x equals 2.807 approximately. We'll usually ask you for 3 decimal places. Now what that's saying is 2 to the power of 2.807 is 7. So if you want to double check, 2 to the power of 2.807 gives me approximately 7. So your steps are, when you have to use the calculator to evaluate logs or to solve an exponential equation that doesn't have a nice easy answer, take log 10 of both sides, move the x to the front, rearrange by dividing by whatever's next to the x, and use your calculator. I will often do a bit of a shortcut. Once I've done this a few times and reminded myself how it works, I can sort of work out that from here I can bring x down to the front and log 10 of 2 down to underneath in the same step. So I will usually actually skip to there once I've done enough practice to work out that yes, I'm getting it right. Now you might get a slightly harder exponential equation. So for example, $50 times 1.1 to the x equals 100. If you've got an extra number hanging out here, get everything you can away from the exercise before you start worrying about logs. So to get rid of times 50, divide by 50 on both sides. So 1.1x is 100 divided by 50. So I've got 1.1 to the x equals 2. After that, you just work down and solve as you would normally. So what's my step now? Take log 10 of both sides. What's my step now?
Make the x on itself and then divide it.
Why is it log 10, sorry?
It's-
Because you're calculating I do log 10.
Oh.
Yep. So the calculator does log 10, so we've pretty much got to convert this.
Log on your calculator just means log 10.
Yes, log on the calculator is log 10. So the x comes down to the front, and if we're feeling very, very clever, where does this log 10 1.1 go? Down the bottom. But if you weren't feeling clever, x log 10 1.1 equals log 10 2 goes in there. So that's quite optional. You're welcome to show all the working. And then you would grab your calculator, log 2, close your brackets, divided by log 1.1, close your brackets, 7.273. And they'll usually ask for 3 decimal places. So we'll stop.